Good evening. In this session, I am going to continue with some interesting problems based on motion in a plane. Actually, we are going to learn so many shortcuts today. So, in 10 problems, suppose if you go for the details given as hints in any other printed book, it will be this long. But today we are going to learn the solutions in a smart way. Okay, very interesting session this is going to be. Now, let us start with the first problem. Look, a swimmer, carefully read the problem. A swimmer wants to cross the river from the point A. This is point A to the point B. Line AB makes an angle 30 degrees with the flow of river. Magnitude of velocity of the swimmer is same as that of the river. That's a very important key instruction given in the problem. Angle theta with the line AB should make. So, you are supposed to find this angle. See here, this is the direction of velocity of water. This is the direction of velocity of water and this is the direction of velocity of the swimmer. And this is the direction of their resultant, because as a result of water velocity, the swimmer finally took this path. So, this is the direction of the resultant. Resultant is making an angle 30 degrees with the flow of water. What is this angle? That is the question. See here, you need not do anything. Just answer me this. When two vectors have exactly the same magnitude, then the resultant will bisect them. That is, if the angle between them is 60 degrees, angle made by the resultant with each of the vectors will be 30 degrees. If the angle between them is 120 degrees, angle made by the resultant with each of them will be 60 degrees. So, here just if this is P bar and this is also P bar, actually two vectors in different directions, but magnitude is same. Then if the angle between them is theta, then angle made by the resultant with any one of them, alpha is equal to theta by 2. So, here it is mentioned in the problem, magnitude of velocity of the swimmer, velocity of water are equal, and this is the resultant direction. Then if these two vectors are equal in magnitude, the resultant will make equal angles with both of them. So, if this is 30, this has to be 30 degrees. So, answer is 30 degrees. See, if you just understand the importance of that sentence, magnitude of velocity of swimmer is same as that of water, then the resultant exactly makes same angle with both of them. This angle is given as 30, this angle will automatically be equal to 30 degrees. Okay, that is actually from parallelogram law of vectors. Now, let us move on to the next one. A person is swimming with a speed of 10 meter per second. Velocity of the swimmer is given as 10 meter per second in the problem. At an angle 120 degrees with the flow. See here, this is the direction of flow of water in the river and he is making an angle 120 degrees with the flow. So, this angle is 120 degrees. So, angle made by the flow with the angle made by the velocity of the swimmer with the normal of the flow will be 120 minus 90, this will be 30 degrees. Actually, if water is still, if he rows along this direction, he finally reaches this point. But what is given? he reaches to a point directly opposite to the other side. He started from this point, he reached exactly the opposite point. So this is because of water velocity. So this represents the velocity of water, this represents velocity of swimmer. So from this, actually what is asked in the problem? The speed of the flow is asked. So I am just explaining you what is given in the problem. See here, a person is swimming with a speed of 10 meter per second at an angle 120 degrees with the flow, and he reaches exactly the opposite bank. What is the velocity of water? So he is moving in this direction, making an angle 30 with the normal of the flow, and this is the water velocity. From that diagram, what is sin theta? Sin theta is equal to opposite side by hypotenuse. So sin theta is velocity of water by velocity of the swimmer, from which velocity of water is velocity of swimmer into sin theta. Swimmer velocity is given as 10 meter per second, theta is 30, sin 30 is half, so the answer is 5 meter per second. So velocity of water is given as x meter per second. What is the value of x? That's a numerical problem. So the value of x is 5 and being velocity, its unit is meter per second. So it is 5 meter per second. Let us move on to this problem. A particle is moving along x direction such that its position is given by x as a function of time is given as 10 plus 8t minus 3t square. Another particle is moving along y axis as a function, its position is represented as a function of time as 5 minus 8t cube. At t is equal to 1 second, the speed of the second particle as measured in the frame of the first particle. So speed of the second particle as measured from the frame of the first particle means you are asked to find out relative velocity of the first particle with respect to, or the speed of the second particle. So relative velocity of the second particle with respect to the first particle is asked. So relative velocity of the second with respect to the first is v2 bar minus v1 bar, and its magnitude is to be found. So how do we find velocity from position? So by differentiating the position with respect to time, you will be getting velocity. So velocity of the first particle, this implies v1 bar is equal to derivative of 10 is 0, derivative of t is 1, 8 into 1 minus 3, derivative of t square is 2t. So at 1 second it is 8 minus 6 I bar, implies v1 bar is equal to 2 I bar. Okay, now you have to find out velocity of the second particle. It is moving along y axis. So again, by differentiating its position, dy by dt is velocity of the second particle, derivative of 5 is constant, minus 8, derivative of t cube is 3t square. Because it is moving along y axis, it is j bar. So at 1 second, v2 bar, t is 1, so this is a minus 24 j bar, minus 24 j bar. So from this, v21 bar is equal to v2 bar, meaning minus 24 j bar minus v1 bar, 2 I bar. See here, you are asked to find its magnitude. Because it is given as root v, you need to find out v. So v21 magnitude is given as a root V, that is equal to square root of 24 square plus 2 square. So 24s are how much? 576. So 576 plus 4, so root V is equal to root 580. So here you have to find V. It is root V is root 580. So V is equal to 580. That is the answer. So the numerical value of V which is given under root is 580. Okay. Next, move on to the next problem. Actually, this is based on uniform circular motion. A particle P is revolving round the center with a radius of circular path R at a angular velocity omega. Very obviously, constant angular velocity omega. As shown in this figure, projection of OP on x-axis at time t is equal at time t is. See here, the most important thing is here it is t is equal to 0. This is the starting point and this is after time t. So you are supposed to find out its projection on x-axis. See here, starting from 0, moving with constant angular velocity omega, its angular displacement is omega t, because angular velocity is angular displacement by time. So angular displacement is omega t. So this is omega t. Then what will be this total angle? Omega t plus 30. Omega t plus 30. 30 can be written as pi by 6. Now this vector r bar is making an angle omega t plus pi by 6 with x-axis. Its projection on x-axis is nothing but its x component. So x as a function of time is, here it is r, its component along x-axis cos, angle made by that with x-axis is omega t plus pi by 6. So the answer is x is equal to r cos omega t plus pi by 6. This is the right choice for that. See here, it is so simple. This is the case. Body has started from this point, reached this point. This angle is omega t. This angle is given as 30 degrees or pi by 6 radians. This is r. So the total angle becomes, suppose if you write it as theta, this is omega t plus pi by 6. So r is making an angle theta with x-axis. Its projection is nothing but x component, r cos omega t plus pi by 6. That is the answer. Okay. Now look into this problem. A clock has continuously moving seconds hand of 0.1 meter length. The average acceleration of the tip of the hand is of the order of, okay. So here this is just, we are worried about the motion of the tip of the seconds hand of the watch. See here, that seconds hand is moving in a circular path of radius r, okay, like this. It is moving in this direction. So acceleration, average acceleration is nothing but centripetal acceleration, because in case of if it is moving with constant speed, its angular tangential acceleration is 0. So the net acceleration is equal to the radial acceleration, which we call it as centripetal acceleration. So in case of a body moving with constant speed in a circular path, its average acceleration is nothing but the centripetal acceleration, that is v square by r, or A is equal to r omega square. Here r is given straight away. So what is the angular velocity of seconds hand in a watch? Angular velocity is angular displacement by time. So it completes one revolution, seconds hand completes one revolution in 60 seconds, right? So its angular velocity will be 2 pi by 60. Radius is given as 0.1 meter. So just to substitute the radius and this in this expression, what will be the acceleration? It is r, that is 1 omega square 2 pi by 60 whole square. So this gets cancelled 30 times. So this is 0.1 into pi square by 900. Pi square, if you take it as approximately, because he asked us to find the order. So pi square is approximately 10. 10 into 0.1 becomes 1. 900 roughly, let us take it as 1000. 1 by 1000 is nothing but 10 to the power of minus 3. So it is of the order of 10 to the power of minus 3 meter per second square. That is the acceleration here. Let's move on to the next. Look here. As shown in the figure, a particle is moving with constant speed, pi meter per second. Considering its motion from A to B, magnitude of average velocity. So what is the formula for average velocity? Average velocity is total displacement by total time. In case of a body moving in a circular path of radius r, after turning through an angle theta, displacement is 2r sin theta by 2 by time. Time is here, it has completed an angle 120. As total angle for one revolution is 360 degrees, the time taken for one revolution is capital T. Then for 120 degrees, the time is going to be T by 3. 120 degrees is 1/3 the revolution. So T by 3. So average velocity is total displacement by total time. Look here. 2 r sine 120 by 2 sine 60 by time period of revolution is 2 pi r by v, because here v is given, it's moving with a constant speed v. So v is pi, so pi and pi gets cancelled, t is equal to 2r by 3. So 2r and 2r gets cancelled, sine 30 is root 3 by 2 into 3, this is 1.5. So average velocity is 1.5 root 3 meter per second. That is the answer, 1.5 root 3 meter per second. This is the hint for the problem. Average velocity is total displacement by total time. Total displacement after turning through an angle theta is 2r sin theta by 2. After turning through an angle 120, the time taken is t. To turn through an angle 120 degrees, time taken is t by 3, 1/3 the time period. Just from that we could get the average velocity. Look into the next problem. A person moved from the point A to the point B on a circular path as shown. Here the angle given is 135 degrees. If the distance travelled by him is 60 meters, then the magnitude of displacement. See, in case of a body moving in a circular path of radius r, say from A to B, after turning through an angle theta, the formula for the displacement is, we know this pretty much well, S is equal to 2r sin theta by 2, right? And distance travelled, distance L is equal to 2 pi r into theta by 360 when theta is given in degrees. So, here displacement by distance S by L is equal to 2r sin theta by 2 by 2 pi r into theta in degrees by 360. Okay. So, this and this gets cancelled. So, S is equal to sin theta by 2, sin 135 by 2 by pi into theta is 135 by 360. So, here the challenge is how to find the value of sin 135 by 2. So, sin theta by 2 is equal to 1 minus cos theta whole thing divided by 2 to the power of half. So, here cos 135 is given, from that sin 135 by 2 is equal to 1 minus 0.7 by 2 to the power of half. Substituting that value here, and on simplification I did the calculation already, the magnitude of the displacement is coming to be 47 meters. But here you have to definitely complete the calculation part at home after saying this. Okay. So, here this is the most important thing. In case of a body moving in a circular path of radius r, after turning through an angle theta, distance is 2 pi r into theta by 360 and displacement is 2r sin theta by 2. Okay. Now, let us move on to this. A particle is moving with a constant speed in a circular path. When that particle turns through 90 degrees, ratio of instantaneous velocity to average velocity. It is given that instantaneous velocity to average velocity, it is given as pi is to x root 2. You need to find out the value of x here. Okay. See here, after turning through an angle 90 degrees. See here, instantaneous velocity is v, say. A body is moving in a circular path of radius, say r, with a constant speed v. So, instantaneous speed is v. Average velocity is total distance by total time, right? Average velocity is total distance by total time. So, here look here. So, average total time taken after turning through an angle 90 degrees, time taken is t by 4, where t is equal to 2 pi r by instantaneous speed. So, this is t here. Is it okay? So, t is equal to 2 pi r by v. So, t by 4 is equal to 2 this much. Is it okay? Now, look here very carefully. I am finding out the average velocity. Average velocity is equal to total distance by total time, or total displacement by total time. Just in the previous problem we have seen, in case of a body moving in a circular path of radius r, after turning through an angle theta, displacement is 2r sin theta by 2, and if time taken is t by t. So, here 2r sin, here theta is given as 45 degrees. So, 90 degrees, theta by 2 will be 45 degrees. So, 2r sin 45 by t is capital T by 4. Capital T by 4 is 2 pi r by 4v. 2 pi r divided by 4v. Just substitute that over here. You are supposed to find instantaneous velocity to average velocity, right? So, instantaneous velocity by average velocity is equal to, it is v divided by, say 2r sin 45 is a root 2r, because 2r sin 45 is 1 by root 2, so that is a root 2r. So, root 2r into 4v divided by 2 pi r. So, this r and this r gets cancelled, this v and this v gets cancelled. So, here this 2 goes 2 times here. So, the ratio is pi is to 2 root 2. That is the answer we got. That is the ratio of instantaneous velocity to average velocity. It is given as pi is to x root 2. It is given as pi is to x root 2. So, on comparison, in place of x you have 2. In place of x you have 2. So, x is equal to 2 here. So, the answer is second option. Okay. So, the problem is simple, isn't it? You are supposed to find the ratio of instantaneous velocity to average velocity. Average velocity is equal to total displacement by total time. Here displacement angular theta is given as to 2r sin theta by 2 by t by 4, because if it turns through 90 degrees, the time taken is 1/4 the time period, and once again time period is 2 pi r by v. Substituting on all those, we got that value. Okay. Now, let us move on to the next problem. A huge circular arc of length 4.5. Arc length is given as 4.4. Ly is light years. 1 light year is given as 9.46 into 10 to the power of 15 meters. That is the arc length given. It subtends an angle 4 seconds. So, angle subtended at the center is 4. When second is converted to minute, divided by 60. When minute is converted to degree, divided by 60. So, angle in degrees is 4 by 60 into 60. This is in degrees. If you want to convert that into radian measure, 4 by 60 into 60 into pi by 180 radian, because we have to convert this into radian, as a radian is the SI unit. Now, arc length is given to you and theta is given. Arc by radius is equal to theta. From this we can find out the radius. Okay. Arc length by theta is equal to radius. From that formula you can find out the radius. How long it would take for a body to complete 4 revolutions if its speed is 8 astronomical units per second. 1 AU is 1.5 into 10 power 11. What else is given in the problem? Time taken. How long would it take for a body to complete its 4 revolutions? So, time is equal to 4 into capital T, where capital T is the time period. How do you find out the time period? Time period is total distance by total time, 2 pi r n by v. Done. See here, n is given as 4, r is given arc length by this theta given in radians, and V is given as 8 into 1 AU is equal to 1.5 into 10 to the power of 11. So, substitute R from this formula, N is given as 4, V is given straight away as this. On solving that, you will be getting that answer. So, just from this, you have to complete the calculation and get the answer. Okay. So, here calculation is bit lengthy, that is why I do not want to waste time on that simple calculation, finish it at home. So, I am just repeating the concept here. See here, arc length is given, angle subtended at the center is given. Arc by radius in circular path. Look, this is the arc length, this is the radius, this is theta. Arc length by radius is equal to theta. From that we got the value of R. Next he asked us what is the time taken for 4 revolutions. If t is the time period for 4 revolutions, 4t is the total time taken. So, how do you find out time period? Time period is total distance by total time. So, total distance for one revolution is 2 pi r, by v is the time period. So, we could find out the time period, substituting that here, we could get the value of t. Okay? That is another problem. Okay? So, this is the key. So, we have completed all the problems given in JEE main from 2019 to 25 based on motion in a plane, that is projectile, relative velocity, resultant velocity, change in velocity, all those problems. Very important concept. Okay, I will stop here for today. Thank you and bye-bye.